Hi everyone. Thanks, Chris, and thanks Russ, because got to see a little bit of what our Groove Rios can do in Russ's presentation there. And this is actually a story that'll also go over Groove Rios. I'm not going to dig deep into the CODESYS part in terms of actually showing their projects or anything like that, but we're going to do a higher level overview of what customers are doing with CODESYS on our products. So again, I'm Dan White, Director of Technical Marketing here at OPTO22. I'll be leading today's session, and with me is my colleague Garrick Reichert. He's one of our senior application engineers. He'll be supporting me at the end and joining for the Q&A. Today's story comes from Point Energy Partners. They're an oil and gas operator in the Delaware Basin. Their challenge might sound familiar: outdated level switches, manual checking, writing down information on clipboards at their saltwater disposal sites. So that left them with little visibility, unreliable data, and a real risk of costly spills. We're going to walk through how they modernize those sites with CODESYS on an edge-based solution running OPTO22's Groove Rio, combining radar-based level sensors, legacy Modbus communications, MQTT Sparkplug B, and Ignition SCADA. They built a control system that's affordable, reliable, and designed to scale. Prevents spills, improves efficiency, and gives operators confidence in their data. Even though this story does take place in oil and gas, these lessons carry over across industries. Any operation that's running legacy controls or needing better visibility at the edge can certainly apply a similar approach. So here's the full agenda. I'm going to start out with a quick introduction to OPTO22, who we are, what we do, and how we've been focused on simplifying automation and connectivity for decades. Then I'll set the stage with the challenge Point Energy Partners faced at their saltwater disposal sites. From there, we'll walk through the solution, how CODESYS running on the Groove Rio was used for edge control and integration, and how it fit in their overall edge IIoT architecture. We'll share some results, impact that they've seen, and then wrap up with some lessons that you can take away and apply in your own projects. And finally, of course, we'll wrap up with Q&A with Garrick and myself and the rest of the crew as well. I think we've saved it all for the end, so that'll be a fun Q&A session. So if you haven't heard of OPTO22, and I'm guessing by now you have because Russ used some of our products in his prior presentation, but just to give an overview of who we are, we're a California-based, privately held company that's been building industrial automation hardware and software for over 5 decades. Our products are installed in the millions at thousands of customers worldwide, and we've built a reputation for reliability to the point that we still back our IO with lifetime warranties. But what really makes us unique at Opto is our engineering philosophy. We combine rugged, reliable OT systems with open, standard IT technologies. That means you can use modern tools like MQTT Sparkplug B, OPC UA, Ignition SCADA, RESTful APIs, and of course, all of that mates with a CODESYS runtime that provides traditional PLC and I/O control. You may recognize some of that hardware shown in the bottom right. I know you recognize the Rio from Russ's presentation, and then there's our Groove Epic controller there as well. Both are designed to give you flexible I/O, control, and connectivity at the edge without locking you into a closed and costly ecosystem. So that's it in a nutshell. We've been doing this for a long time. We're known for reliability, and we focus on openness so that you can build your systems the way you want. And real quick, here is a look at our headquarters from overhead from a drone shot at our headquarters in Temecula, California, about an hour north of San Diego. This is where all of our products are designed, manufactured, supported. Everything is built and tested here under one roof. And that's important because it gives us tight control over quality. It means when you call us for support, you're talking to the same engineers who build and use the hardware. And so now that you've got a good sense of who we are and where we come from, let's shift into the kind of problems that we solve and how Point Energy Partners put those solutions into use in today's application story. So again, we're a company of engineers trying to solve the problems that you see every day in industrial automation. And so this overview here kind of talks about the problem we're trying to solve. I'm sure many of you guys have seen architectures like this with layer upon layer of systems that are disconnected or unsecurely connected in this automation stack. And We're here to say that the automation status quo will not suffice. Using devices like the one Point Energy partners use and like the ones that we make, you can simplify that architecture and provide valuable production data from your sensors and from your controllers directly into uh, to stakeholders across the business on cloud, on prem, and you can do all of that with the best cybersecurity tools on the market. Okay, so before we dig into the technical details, let's give you a quick view of who is Point Energy Partners. So they're an independent operator in oil and gas working in the Delaware Basin, which stretches across West Texas and southeastern New Mexico. Now, that region has been one of the busiest oil and gas plays in the U.S. over the last decade. PEP is led by industry specialists and U.S. military veterans Brian Moody and John Sabia. And in the past 5 years, they've grown their production significantly, especially in midstream assets like the saltwater disposal sites we'll be talking about today. Now, that's something interesting about PEP. They aren't just focused on pumping oil and gas. They also run this substantial water recycling program, which is a big part of their commitment to sustainable operations. That mindset carried over into this project. So, preventing spills wasn't just about the money, it was also about environmental stewardship. And that's who they are. They're a fast growing operator focused on sustainability who needed to modernize controls at these SWD saltwater disposal sites. So, Point Energy's operations here at the saltwater disposal sites. Now, if you're not too familiar with saltwater disposal sites, here's what that means. Whenever you're drilling to produce oil and natural gas, you also bring up a lot of byproduct water. There's mixtures of groundwater, drilling fluids, ultimately water that's packed full of salts, hydrocarbons, and other compounds. So it has to be managed safely. At an SWD site, the water is collected in large tanks and then injected deep underground into disposal wells. Now, to do that safely, you need reliable monitoring and you need pumps to move the water, and you really need a way to oversee that whole process. Now, again, these sites are critical because they're both protecting the environment and the company's bottom line. So if a spill happens, you're looking at cleanup costs, downtime, and potential fines. So yeah, the stakes are pretty high. Here's the situation that they were dealing with at Point Energy Partners at their sites. The existing tank levels were being monitored by old hydrostatic head switches. So meaning they were moving parts with floats that would tell you how high the fluid was. Now, over those times, especially with water that's so caustic, like the stuff that they're bringing in, you'd have those sensors starting to fail, unreliable sensors. Now you have operators having to go on site and check tanks manually. And so you're getting inconsistent data and, in a lot of cases, no way to know what was happening until you were physically on site. Starting out, they didn't have a centralized SCADA system in place for visibility. So if a tank did start creeping toward an unsafe level and those hydrostatic switches weren't working right, they had no way to see that remotely, no alarms to warn them. And so the risk was real. Their own internal studies showed that each time one of those saltwater tanks overflowed, it would cost them about $200,000 in lost time and cleanup. And that's not counting environmental consequences and regulatory attention that comes when you have a spill. But there was also a big budgetary challenge. A lot of what they found for off-the-shelf PLC solutions were about $10,000 per panel. They were just overkill. They were too expensive to scale for these existing sites that were already running, and they didn't have big budgets to improve. So what they needed was something reliable, modern, and cost-effective that they could roll out widely. And that's the challenge that they set out to solve. So from those challenges, these are the requirements that really rose to the top. First, they needed accurate, reliable tank monitoring. Those old hydrostatic switches weren't cutting it. So going with like a radar style sensor that had no moving parts that use ultrasonic waves to measure the fluid levels was an obvious choice for them. Now, they would need a platform that would be able to take the physical I/O from those sensors. So physical I/O, of course, was a requirement. Along with that physical I/O, they wanted automated pump control. So instead of having operators making judgment calls and pumping things down, they would now be able to start and stop based on those tank levels automatically. So in addition to I/O, they needed something that had a PLC runtime, and ideally something that supported an IEC 61131-3 for ladder logic and function block program that their developers were familiar with. They also needed remote visibility. They were just getting into developing their SCADA. In their case, they had started experimenting with Inductive Automation's Ignitions platform. So they knew whatever hardware that they chose, it would have to integrate smoothly with the Ignition platform. It also had to be scalable and, of course, as we said, affordable. They were hoping to find some kind of a solution around roughly $1,000 that could deploy broadly across their sites. And finally, legacy support was a must. They still had some older sensors out there and transmitters that were running both Modbus RTU serial and Modbus TCP communication. So this new solution had to bridge the old legacy serial protocols as well as older Ethernet protocols with new modern IIoT friendly protocols like OPCUA and MQTT Sparkplug B. And so that's the checklist that they were working from. Now, of course, one option that they did consider was going the more traditional PLC route. Now, with a centralized panel at each site, something like you see there in the image, but that approach came with some serious drawbacks. First, these types of panels were typically around $10,000 installed. And, when you multiply that across all their sites, it really became a non-starter. They couldn't even get management to buy in and agree to do any automation at that price. Now, secondly, I don't have to name names, but many of those PLC systems that we're talking about use proprietary programming software. They lock you into a vendor ecosystem that requires ongoing licensing, costly support contracts, just to get a little bit of help. And then finally, what these systems was really just overkill. For what they needed, tank level monitoring, pump control, some remote visibility, a full-blown high-cost PLC panel was just more than they needed. So while it seemed like, maybe this is the default choice, this is what everyone else is doing in the industry, it didn't make sense for PEP. So they needed something more modern, more open, and affordable that scaled with their operations. So here's how Scott Adams, PEP's automation engineer, described their search. You can see his quote right there. They knew that they needed I/O that would fit with their new Ignition SCADA system. And honestly, their approach was pretty simple. They just went to Google and started searching MQTT, Ignition, Control, I/O, and OPTO22 just kept popping up. Now that's important because it highlights two things. First, they didn't want something, a traditional PLC with a heavy, expensive footprint. They wanted something modern and open that would fit with open standard protocols and plans for the architecture that they were already moving towards with Ignition and with an MQTT Sparkplug backbone. But also it shows how discoverability matters. When you align your products with open standards like OPCUA, MQTT Sparkplug B, unlimited licensing, Ignition, and of course, an IEC 61131-3 platform like we have in CODESYS, the customers find their way to you. And so now this is really the heart of the solution, the Groove Rio Edge module. And thanks, Russ, for going over some of what Rio can do. Here in PEP's case, they chose Rio for a few reasons. First, it's incredibly flexible I/O. So with those 10 points, each channel being software configurable, the same device, the same part number can handle digital, analog, thermocouples, pulse inputs, counters, you name it. So with one piece of hardware, they could handle their radar sensors, their pump contactors, read-in turbine flow meters, all with just one device, with not choosing separate I/O modules. Then, of course, you've got a built-in CODESYS runtime license. So we license CODESYS on Groove Rio for a one-time charge of only $100 per unit. That gives them local control right at the edge without needing a separate PLC panel. The pumps could run locally and automatically based on tank levels, and it was all fully independent of the SCADA system right there at the edge. Of course, communications was a big part. With Rio speaking MQTT Sparkplug B natively, it made it really simple to tie into their Ignition SCADA. And of course, it supports things like store and forward data redundancy to fit their broader IIoT and data collection strategy. So then the other thing is you've got Modbus RTU and Modbus TCP support. So legacy transmitters that were already out there in the field were covered, and they wouldn't leave any data stranded out in the field. And then the cost, around only about $1,000 per unit. Scott described Groove Rio as the Goldilocks solution, right? Not too big, not too small, just right. Not an over-engineered $10,000 panel, but neither a stripped-down micro PLC that just did one thing and couldn't fit their needs. And finally, it was easy to deploy. Scott told us that their technicians, even the ones without deep PLC experience, were able to commission these systems themselves. That's because Rio, everything within the Groove Rio is done within a web-based management tool called Groove Manage, which is all click point, drag and drop, entering fields and clicking checkboxes. No custom code required, really, aside from their PLC programming and CODESYS. So for PEP, it checked all the boxes: flexible I/O, local control, easy integration, affordable to scale, and simple to commission. So one of the reasons that that Point went with Groove Rio is that it isn't just a piece of I/O hardware. Like I said, it sort of sits at this intersection of OT and IT. This diagram, which we show all the time, showcases that flexible architecture. Down here in the bottom, you've got your OT side where you can directly connect to field devices like physical I/O, pumps, conveyors, motors, and so on, along with PLCs and controllers as well through the Ethernet interface. And in Point Energy's case, this is where they're bringing in their radar transmitters, their pump controls, as well as some of those Modbus TCP and RTU communications I mentioned. At the edge, this little device can run CODESYS for local control. And you've also got other tools like Node-RED for some integration logic. And of course, it publishes data natively over MQTT Sparkplug. So then on the IT side, it'll safely and securely integrate with Ignition, with various cloud platforms like AWS, Azure, Snowflake. And it even supports all of your favorite cybersecurity tools, including OpenVPN for secure remote access. So while PEP deployed Rio at these saltwater disposal sites for tank monitoring and pump control, the bigger picture here is that this same device could be a bridge between OT and their SCADA, their Historian, and even cloud-based systems. It's not just solving one problem for them. It's a platform that they can keep building on to continue to add more intelligence to their process. So here's what PEP's saltwater disposal sites look like. Here on the left, you can see water coming up as a result of the oil and gas drilling. Now that water gets pumped up into these collector tanks. As I mentioned earlier, those tanks are now being monitored with these new radar level transmitters for accurate, consistent data without moving parts, without getting mucky and dirty, because they just sit at the top of the tank and shoot a signal down and it bounces back up. Along with that, they've got Modbus signals that feed into the Groove Rio, as well as the Groove Rio's Edge I/O. So each Groove Rio, which is running its own CODESYS platform, is now acting not as just a data collector. You've got a controller, you've got automatic pump control, and you've got all the tank monitoring without having to wait for anybody at the SCADA site, all being controlled and run locally at the edge. At the same time, all of that data gets pumped up over MQTT Sparkplug. And so now operators get all that visibility at the SCADA level and in the Historian. They also used a little bit of Node-RED on their Groove Rios to facilitate communications with these older serial-based Modbus devices. So the Rio will support a USB to serial converter that'll communicate, RS-485 and RS-232, in their case, 485 to these Modbus RTU devices. So that way they didn't have to tear out these existing pressure transmitters and older gear. They could use the older gear that was still out there, and it could all be part of the same data stream and the same data ecosystem. Now, they run all of this using Radiant wireless mesh radios and also Netronics PoE switches. So the Rios themselves don't even need power supplies out there in the field. You just drop a PoE line to the Rio, and it's on your network. And then they used these Radiant wireless mesh network to communicate across the entire site. And so the big result was they prevented the spills we talked about. Since they've implemented this solution, they haven't had a single spill. And as I mentioned, each one would have cost them about $200,000 just operationally, not including environmental or regulatory fallout. They've now got quality, reliable data along with real-time pump control, all tied to those real-time tank levels So operators aren't stuck running out and doing manual checks. Instead, Ignition now gives them full visibility across their sites with alarms and the historian built in. And all of this was deployed affordably for about $1,000 per unit. Those Groove Rio MM1s actually list for under $1,000. Throw a $100 CODESYS license on there. You're right around $1,000 rather than a big $10,000 PLC panel. So now it became more realistic to say, hey, we did this here for only $1,000. What else do we want to do? And that's the big story here on the management side. So PEP's management, they originally weren't even sure about doing automation at these sites. They felt like, these sites just support their operations. They're not big money makers. We can't be putting thousands and thousands of dollars into automating and modernizing. Well, after this project, where the affordability and immediate success in making their operations easier just proved out that the ROI was immediate and clear. So this small project really shifted their whole perspective. It opened the door to more automation and more IIoT initiatives across their portfolio. And so if you want to learn more about Point Energy Partners and their particular application and what they did with CODESYS within Groove Rio, definitely check out their case study. It's available on our website, OPTO22.com. And from there, if you want to learn how you can get started, we also offer free training, free support, and free application engineering assistance. Here you can see a screenshot here from our training site, which shows basic training on how to get started with a Groove Rio running CODESYS and actually getting all the way through applying licenses and getting up and running with a real control program. You might use a product like this Groove Rio Learning Center down in the bottom middle there, and that is how you can get started.